All right, so off we go to problem 21, the last one, half-lives, application of exponentials. These are problems that can be a little bit on the tough side. So quite a few ways that we could actually approach this problem. So I'll kind of take you through this little piece of information. So keep in mind, in exponentials, we can have all sorts of different bases. So usually in math, we really like to go with this formula if ever possible. That's CE to the KT, where C is actually, it's the initial condition that we would have. And in problem number 21, it said that we had 7.4 grams initially and that its half-life was 14 days. Now, this is a completely legitimate way to do this problem, but as it turns out, it's a little bit harder. And so I think I'm going to go the easy way, and then I'll kind of steer over and kind of just give you a little bit of an idea of the slightly harder way. But there's a reason I like this way actually a little bit better, even though it is a little tougher. So if we look at it in another way, which is just sort of like A times B to the T power. Notice it's a little bit different. We don't have a qualifier on time. So in this problem, our initial condition was given to be 7.4 grams. So that's going to be A in this case. It was also going to be 7.4 in this one, although I'm not going to carry on and keep going back and forth, but I did want you to see that it's the same. Now, the thing is it is set up to give you a half-life problem. So it's always going to be doing half of. It's always multiplying something by half because you have half of it left. Now, if we did this, half to the T, that means every time T grows by 1, every day it cuts in half, but that's not what happened. It says it happens about every 14 days. So every time time grows by 14, so on the 14th day it would be half, on the 28th day it would have been cut in half twice. So that's kind of where our story is. So that makes it a very, very easy value. So if I wanted to know what is the value of this function after 234 days, then I really fast have my answer. I just have to plug into this. So let me go grab the calculator again. Let's see. So we would have 7.4 times 0.5 raised to the 234 divided by 14. So how many of those 14-day chunks have happened that continuously cut us in half? So this actually tells me it is a very, very small number. In fact, it's a surprisingly small number that would be left after 234 days. That's 6.88 times, actually 6.882. I like to give 3 decimal places times 10 to the minus 5. Would be the value left after 234 days. Now you can see that 234 divided by 14 is 16. So the thing got cut almost 17. The thing got cut in half almost 17 times. So if you started at 7.4 and you cut it in half once, twice, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, almost 17 times, you can kind of see that's what's happening with this problem. You've cut it in half over and over, and there's very, very little of it left. Now, when it says, when will there be 2 grams left, I'm going to go back to this equation, and I'm going to set it equal to 2. Now, when we're looking for that value of that exponents, that's when logarithms are going to come into play. So I'm going to divide both sides by 7.4. That allows me to isolate the exponential portion of this question. And now we're going to play some log games. Now, my favorite kind of log is a natural log because it's base E. I kind of referred to that over here. So when you take the log of both sides, you're going to have something like this, because a property of logarithms is that the exponent in here becomes a coefficient. So the only thing left to do to get the time by itself, one, is I'm going to multiply both sides by 14. But I'm also going to divide both sides by the natural log of 1/2. Now, we usually don't like decimally answers, but this is a decimally question. They had 7.4 grams of it, and it's not looking for this ultra precise thing in a way that we would in math, like where we want infinite precision. It's a little bit more relaxed. So I'm going to take 14 times the natural log. I'm going to be really careful about my parentheses, divided by 7.4. And then I'm going to take that number. Now that might surprise you. I got a negative answer right here. But I'm going to divide by that by the natural log of a half. And that is also, by the way, a negative number. And so I got a positive. So according to this, it would be about 26.425 days would be approximately the moment. So that's almost identically 2 half-lives, because 2 half-lives would be 28 days. And so let's see what happens. 7.4, if we cut it in half once, and we cut it in half twice, see how 1.85, by the end of the 28th day, it'd be 1.85. That was a little bit too much, so that makes sense that it was a little bit less. Now, if we wanted to look at this as the other version, which I'm not going to complete, I'm just going to get it started, what we could do is we could look at this problem through the following lens. I know that the half-life is 14 days. So when t is the number 14, I know that this value is going to be 3.7 because it's identically half. Divide both sides, we get a half. No big surprise. Now, if we take the natural log of both sides, this is 14k, and so k is 1/14 the natural log of 1/2. And so now what I have is a master equation. And that may look worse to you, but there are reasons why in a calculus class we actually tend to like things written in A base E. You'll learn why soon, but we could actually answer all of those questions through that lens. Hey, you have a wonderful day. We are done. Have a good one. Goodbye.